Myself, I am Dr. Jntuh. In this class, we are going to discuss about the memory protection and shared pages concept. Moving to the first topic, that is memory protection. As we know that memory is an important sequence in the OS. It is used for storing the multiple number of variables in a sequence. Memory protection is another important parameter that is implemented by the particular memory of a user that can be interrupted with the associating different number of bits. While protecting the particular number of bits, we are going to associate the particular bit in each number of frame. Whether it can be indicated in two modes. One is read-only mode and another one is read-write access mode. We can use two different types of bits. One is a valid bit and another one is an invalid bit. Valid bit is nothing but it indicates the associated pages which is in the progress, which also related to the logical address space of a particular process. Invalid bit indicates that the page that is not particularly takes part in the process, so that the logical address space of the particular table will be there in the PTLR, that is nothing but page table length register. So it will be listed there. Whenever we want to take part in the participation, the invalid pages can be converted to the valid pages and move into the sequence. So this is how a valid bit and invalid bit participated in the memory protection. So this is a diagram explaining the valid and the invalid bit in the page table. For example, here there are 6 different types of pages which are stored in different memory location. Here the frame number of the particular page table has been listed, and this bit is indicating whether the particular number of sequence of a page number related to the frame number, which is valid or invalid bit, like that. V represents the valid bit and I represents for invalid bit. So the invalid bit does not take part in the participation, while only the valid bit only takes part in the participation. Okay. Invalid bit will be moved to the PTLR register and it will be stored there. So the next concept is shared pages. So shared pages is nothing but we are going to share a code between the different number of processes. So one of the copy of the particular file that is in the read-only mode can be shared among the different types of processes. For example, we can share it in the text editor, compilers, and Windows system. Here the inter-process communication will be takes place between the particular process. Whether the pages can be read or write the pages is allowed in this type of frequencies. So after that, what is a private code? Private code is nothing but the pages that are needed for doing a process will be having a logical address. So the pages are protected with a particular code. So the code will be accessed only by the authorized user. The unauthorized user cannot open the particular page by using this private code. For example, data is nothing but the data is the information which we are going to share in the particular page. Each process will be having a separate copy of particular code and the data here. So this is a concept of a shared pages. So this is an example of a shared page process. Here the process 1 and process 3 are listed. Different types of edges of the pages and data has been shared here, and these edges will be processed by using the different types of sequence. Combining these 3 processes, for example, process P1, P2, and P3 will be combined together, and which are all the pages having the valid bit only going to take into the consideration. Okay. So likewise, we are going to combine the 3 values of a process. For example, here the common value is ED1, ED2, and ED3. In the process 1, we are having a data 1, data 2 in process, and data 3 here. Okay, combining these 3 pages, we will be having this combined sequence here. Data 1, data 2, data 3, ED1, ED2, and ED3. Likewise, the pages has been shared here. So the next topic is structure of a page table. A page table is nothing but we are going to store our data, that is logical number of data in a data structure mode. As we know that in a data structure mode, it will be having a tree-like structure. The parent is there. Depending upon the parent request, the child has going to be created for the particular process. Likewise, in a virtual memory also, a data structure is there that is used for storing and mapping of the particular information of a page between a virtual address and the physical address. So this is the main work of a page table. So what are all the characteristics of a page table? Page table can be stored in the main memory. It cannot be stored in the secondary memory. So it can be calculated by total number of entries that has been calculated in the page table, which will always be equal to the number of pages in which the process is going to be divided into a individual sequence. Here, each process has its own independent page table. This independent page table having the several information that not to be restricted within a sequence manner. Like that, we can store a page with a virtual address as well as a physical address, which will be mapped to the logical address and store in the page table registry. So next, moving to the page table entry, a page table entry will contain several number of information about that particular page. For example, the information contained in the page table entry will be varied from one of the operating system to another system. For example, in a Windows, the page table entry may be vary, or in the Unix system, the page table entry will be vary. For example, some of the pages will be having a frame number, page offset value, and the default value. Like that, the storage of the operating system will be differ depending upon the page table entry. So this is a page table entry format. Here a page number is there. After that, particular page is present or absent, in which mode it is protected, whether it is giving the protection for a read mode, like write mode, like that. After that, the reference bit indicates that the page has been referenced in the last cycle of a column. For example, whether the particular page has been indexed to some other pages, like that. After that, catching is that. Catching is nothing but whether the particular bit that is takes part in the paging has been disabled or enabled to the particular user, like that. Catching is performed here. Dirty is nothing but it is sometimes called as a modified bit. The bit which is specified here, the page can be modified or not. So these are all the table entry format. So frame number is compulsory for all the page table entry. So these are all optional field depending upon the content of the field. Okay. So as I repeat this, frame number is nothing but whether the particular frame is stored in the page memory or not, main memory or not. Present or absent is nothing but whether the particular bit is a valid bit or invalid bit, whether it is stored in a main memory or not. Protection bit is nothing but read write bit, which page protection has been given to the particular page, like that. Reference bit is nothing but the page has been referenced or indexed, time has been given for the particular clock cycle. After that, catching is nothing but the bit is going to be in an enable format or a disable format depending upon the freshness of our data. Dirty is nothing but the bit is sometimes called as a modified bit, whether the particular page has been modified or not. Moving to the next one, that is structure of a page table. So as we know that page will be having a data structure that will be stored in the main memory. The common three techniques that are used for the page table classification are hierarchical paging, hashed page table, and inverted page table. Moving to the first one, that is hierarchical paging. Multi-level paging is otherwise called as a hierarchical paging. Here the pages is size of the pages is very large and it can be fit into a contiguous space. In this paging, the logical address space is broken into multiple number of pages because the memory size is very, very large. So the purpose of using this hierarchical paging is dividing the particular page into two different type of classification. One is 2-level page table and another one is 3-level page table. For example, considering a memory size 512 MB, here this can be represented in the form of a physical address, that is 2 power 29. So this physical memory will be divided again into the 4 number of frames which can be fit into the physical memory. For example, the physical memory is 29 and the frame size used here is 12 and the number of bits which we are going to be used is nothing but physical memory minus number of frames size in the bits. So 29 minus 12, the size is 17. Like this, we have to simplify the large memory space from the physical memory to the normal mode. Okay. So after that, how this process of hierarchical paging is done is explained with this help of the diagram. Here, a page will be having a frame number, as we know that. Also, the frame size or offset value is set for the particular page. So the frame number is represented as A4 and the frame size or offset value is represented as D. Here, the particular field is divided into 4 KB, that is divided into equal halves, so that the physical memory will be occupying the total number of frames in the sequence. Likewise, earlier in the process, which we divided the particular physical memory in the terms of logical address that we are converting. After that, we calculate like the same way. Here also, we have to use that same sequence. Okay, so this is also another example, that is a logical address here represented will be having the page number. There we use the frame number and offset value. Here we are going to use the page number under offset value. Okay, so here also we are going to use the same process, but there we consider the physical address. Here we are going to consider the logical address as being calculated with the help of this 2 powers, and this has been calculated as 2 power 32 and the page size is 12. So dividing this logical address to the page size, we get the total number of pages would be occupied in that particular memory. So like this, we have to make the calculation for the physical address as well as the logical address. So as we know that the data structure format has been used in the hierarchical paging, it can be capable of dividing the page table entry into 2-level page table and a 3-level page table. So 2-level page table is nothing but we are having a 32 logical address space and a page size of 1 KB, and it is further going to divide the particular page number by using the page offset value. Here we are having a page number consists of 12 bits and page offset value consisting of 10 bits. So this can be divided into 2 sequence. The page number is one side it having 12 bits and another side it having 10 bits, and the page offset value is a default value and it is represented by 10. Okay, here the 22 number of page number has been split into 2 because the memory size of the particular page is very large. So dividing the particular page number into 2 number of bits, after that the page offset value is a fixed one. So like this, we have to make the particular sequence of a number of a page table. So this is another example of page table entry. So here the P1 is called as a outer page table entry and P2 is called as a inner page table entry, and it is using this technique that is called as forward map page table, because the process has been moved to the forward of the sequence of the process P1, P2 and the page offset value. Okay, so this is a diagram for explaining the 2-level page table scheme. Here the process P1, P2 and offset value of the field has been indicated. The process has been, the pages has been used here or move forward. That type of sequence is called as forward map the table to the process P1, P2 and P3. Like this, we can use this 2-level page table scheme. Okay. So this is also an example for the 2-level page table scheme. Here the outer page table has been forwarded to the particular page table to which it indicates. For example, the pages from 1 to 500. After that, 100 to 708. Like that, the page tables are there. The page tables are moving forward and stored in the frame number as well as the main memory, like this sequence. So by using this, we can avoid the congestion in a particular network. Okay, so this can be used by the page table entry scheme. So the next category is 3-level page table entry. Okay. So as we used 32 number of bit logical address, but here in the 3-level page table, we are used the 64-bit logical address. This is the major difference between the 2-level page table and the 3-level page table. Here the pages will be having a outer page, inner page, and the offset value. Outer page is represented as P1, after that P2, after that D, that is a offset value. Okay. So likewise, we are representing the particular bit. Here the 64-bit has been divided into 42, 10, and 12. Like that, we are going to divide the particular pages into the different types of values. Here another concept is called, that is hashed page table entry has been used in the 3-level sequence. Hashed page table is nothing but we are going to entry the each pages in the hash table will be having a linked list elements. So the linked list element is nothing but we are going to map the pages with the main memory in a particular location. For example, if we are going to store a file in the system, we will mention that our file name .c will be going to store in a document. So by using this reference, we can retrieve a file. Like that, the page table entry will also have to store the particular file in a particular location and the directory in which we are going to store. Okay, this is a use of a hashed page table entry. Here, each element will consist of a 3 field, that is virtual page number, the value of the matched page frame, and a pointer that is pointing to the next element existing in the linked list. So these are the 3 categories of a hashed page table. Okay, so what will be the algorithm worked here means the each page table having a virtual page number. Each virtual page number will be having a virtual address and it is hashed to the hash table. There is then compared with the particular field, whether the particular hash field indicating the field 1 or field 2, like that, it will check for the condition in the virtual page number. If there is a match in the particular number and a corresponding page number field is 2, then the desired physical address will be allotted to the particular number. Otherwise, if there is no match, means subsequent entry that is entered in the linked list will not match the particular virtual page number. If it is not matched, means it will be moved to the queue. Okay, in this scheme, we can address a 64-bit address space by using the concept that is called as clustered page table. So which are all the matching will be come under one category, which are all not matched with the particular field 2 will be moved to the next category. So next concept is clustered page table. Clustered is nothing but a collection of elements that is stored under a common name that is called as a cluster. Here the hash table entry will be having the different type of pages. Each will be occupying in the contiguous memory space. So those memory references are indexed by the particular value. So this is a diagram for a hashed page table entry. Here the hash function is going to be performed. Which hash function we are going to perform? For example, virtual number of the particular page has been given to the particular page and it is stored in the hash table. After that, a function is going to be divided into 2 categories, that is logical address, that is page number, and offset value. After that, the particular page number has given a read permission and offset value, and finally it has been stored in the physical address. Like that, we have to store the page table entry in the hash table. So after that, so the next concept is inverted page table. Here, this is somewhat different from a hash table entry. Each entry in the particular page memory will contain the virtual address. So there will be having a logical address and physical address, but here the pages will be having a virtual address and it can be stored in the real memory location. Okay. Each time the value of a memory will be decreased needed to store from the each page table. Otherwise, each time the value may be increasing depending upon the page reference number. So this is an important concept here. Whenever we are going to read the particular pages, it will decrease from the particular page. Whenever we are going to add the number inside a virtual page table, the value of the pages will be get increasing while adding the particular pages. So this page is called as a reference page. Okay. For this inverted page table, each will be having a virtual address. So this will be having a triple format, that is process ID will be there. After that, page number will be there. After that, offset value will be there. Each inverted page table entry has a two types of pair. One is definitely it have a process ID. Process ID is nothing but whether the particular role of address identifier will containing the virtual address or not. Like that, represented is called as a process ID. Page number is nothing but corresponding page of a table. It has been matched or not. Both will be stored in the main memory system. After that, offset value is nothing but we are going to indicate the address of a page. Physical address is mapped with the virtual address. The value has been found or not. Like that, it is called as an offset value. If the particular match has been found for the particular table, then the physical address is going to be generated with the virtual address. If the match is not found, means illegal address has been provided and the particular entry has been considered as a duplicate entry and it will be moved out of the page table. Okay. So after that, segmentation. So segmentation is also similar to the paging technique. Paging is a technique, as we know that paging is a technique that provides the particular user view of a memory, both in the physical memory as well as in the logical memory. In some of the cases, they provided the virtual memory also. But the segmentation is divided the pages into number of segments, and the segments has to be take part in the main memory segment. So that is called a segmentation, dividing a page into total number of equal sizes. That is called a segmentation. As we know that segmentation is also a memory management technique in which the memory here is going to be divided into variable size part, and each part is known as a segment which can be do a particular process. Segmentation also supported by different types of programmers. Here a logical address space is called as a collection of segments. Here the logical address space is called as a collection of segments. Each segment of a user program will be having a variable of length, and the length of the segment is decided by the user which we are using. Here in the segmentation, we are having a particular field specifying both the name and the length. For each implementation of the segmentation, segments are numbered like the page number has been used in the paging. Here the segments are numbered and it is referred by a segment number. Okay, like that we have to save the segment in an equal size. So this is a logical address containing two tuples. One is segment number, another one is offset value. Segment number is used to represent how many number of bits that are required to represent a segment. For example, if a segment need 10 means, so it represents 10. Like that, it is going to be represented. So next one is offset value. Offset is nothing but it is used to represent how many number of bits that are required to represent the size of a segment. Okay, so in a C compiler, we can separate the segments in the different types of forms. One is a code, after one is a global variable, heap, which is being allocated from the main memory, stack we are using from a thread, and a standard C library. So these are the different types of formats of a segmentation. Okay, as per the programmer's view of segmentation, it is divided into stack, symbol table, main program, square root. After that, subroutine. Okay, segmentation part 1. Okay, so here the implementation of segmentation has to be done in a two-dimensional user format. This can also be done into one-dimensional user format with the help of the physical address. So this mapping of two-dimensional user-defined address to a one-dimensional physical address is called as a segment table. The table here will be used to store the different types of information about all the segments of a particular process. So this table is called as a segment table. Okay, so normally the table will store the base address of the segment table, and this is called as segment table base register. Each entry in the segment table base register have a segment base and a segment limit. So it specifies the length of a segment. So the logical address here consists of two parts. One is a segment number and another one is a offset into the segment. Move to the one, every time the segment number will be having an index number which is reference to the particular segment table. The segment number is legal or illegal in two types. Legal is nothing but it is added to the segment base and it produces a correct address of the physical memory in a desired path. Illegal is in the sense, so the the physical memory that is not being produced in the address and the segment base is not there in the limit. So that is called as a illegal offset. So the segment table, the condition is yes should be lesser than the segment table length register. So this is a diagram explaining the segmentation hardware. Here the CPU is going to divide the segmentation and offset number, and segment is divided into two types of register. One is a base register, another one is a limit register. Okay, the base register and the limit registers are executing the condition in a correct manner. If yes means it will produce and passes the segment table to the physical memory. Otherwise, the base register and the limit register values are differ. If it is a found that is a illegal page, it will report with the addressing error. So this is also another example and the user's programming view. So it is divided into, as we know that it is divided into 5 different parts. That is subroutine, square root, main program, stack, and a symbol table. Okay. So each segment table will be having a limit register and a base register. For example, here we can say that the segment 2 will be having the address range that is varies from 4,300 to 700. Here the difference of a value is 400. Like this, the segment value has been divided and mapped with the segment register. So after that, we can see the difference of paging and the segmentation. So we have to compare the both because both are similar. Paging is a main memory management technique and segmentation is also a main memory management technique. Both were same. It is partition and fixed block size has been used. So the block size has been called as a pages. Here, the memory is going to be divided into variable sized blocks that is called as a segments. So with the paging, the logical address is going to be divided into page number and the page offset. Here, the logical address is going to be divided into section number and section offset. The technique used here is called as internal fragmentation. Here, the segmentation using a technique called as external fragmentation. In the paging, the page size is decided by a particular hardware. Here, the page size is decided by the particular user. In order to maintain a page table, the page table is created and the paging concept has been used. In order to use the segment data, the segment table has been created. Here the base address will be having in the page table. Here the segment number and the offset value will be there. So this will be comparatively faster. Paging will be comparatively faster than segmentation. Segmentation is slower compared to paging. Thank you.